So far, we built our infrastructure using Azure and Terraform, but there are still two important challenges. What happens if our server goes down, and how do we configure our machines automatically? In this video, we'll solve both by introducing Azure High Availability and Terraform Provisioners. Alright, before we jump into the technical part, let's quickly look at what we are going to cover. On the left side, we have Azure High Availability. The goal here is to make our infrastructure more reliable. So even if a VM fails, our application stays up. On the right side, we have Terraform Provisioners. Here, the focus is automation. Instead of configuring machine manually, we run scripts and set everything up automatically. So by the end of this video, we'll have infrastructure that is highly available and fully automated. Now let's talk about high availability in Azure. So when we design our infrastructure, we need to decide how to distribute our virtual machines across those data centers. In Azure, we mainly have two options: availability sets and availability zones. On the left side, we have availability sets. This is where we distribute our VMs within the same data center, but across different hardware and update groups. On the right side, we have availability zones. Here, we go one level higher and distribute our VMs across different data centers inside the same region. So the key idea is simple. Sets protect you inside the data center. Zones protect you across data centers. Now, let's take a closer look at each one in detail. As we mentioned earlier, availability sets work within a single data center. The goal here is simple: avoid having all your virtual machines fail at the same time. Azure does this by distributing your virtual machines across two important concepts: fault domains and update domains. Let's start with fault domains. A fault domain represents a group of resources that share the same physical hardware, like the same server rack, power source, or network switch. So if one rack fails, only the VMs in that fault domain are affected. The others continue running. Now let's talk about update domains. Update domains are logical groups used during planned maintenance. When Azure performs updates, it does not update all VMs at once. Instead, it updates one update domain at a time. So some VMs stay online while others are being restarted. If you look at the diagram, you can see that VM1, VM2, and VM3 are placed in different fault domains and also in different update domains, which means they are protected from both hardware failure and planned maintenance. So the key takeaway is availability sets protect your application inside the data center by spreading your VMs across hardware and update boundaries. But remember, if the entire data center goes down, availability sets alone are not enough. And that's where availability zones comes in. So let's talk about availability zones. Imagine you deploy your application, everything is running fine, and suddenly one entire data center goes down. Not just one server, not just one rack, the whole data center. If all your VMs are in that data center, your application is completely offline. This is exactly the problem that availability zones solve. Instead of placing your VMs in a single data center, Azure distributes them across multiple data centers within the same region. Each zone is completely independent with its own power, cooling, and networking. So now, if one data center fails, your application is still running in another zone. As you can see in the diagram, VM1 is running in zone 1, VM2 is running in zone 2. So even if zone 1 goes down, zone 2 continues serving your users. Now, on the right side, We also have something called region pairs. This takes it one step further. If an entire region has a major outage, Azure can fail over the another region. So the idea is availability zones protect you across data centers, region pairs protect you across regions. And this is what we use for critical production workloads that cannot afford downtime. Now let's talk about Terraform Provisioners. Imagine this. You deploy a virtual machine using Terraform, everything looks good. The VM is created, but then what? You still need to install software, configure services, and prepare the system. So you log into the VM, run commands, do everything manually, and repeat the same process every time. This is doesn't scale. This is where provisioners come in. They allow Terraform to run scripts or commands right after the resource is created. So instead of doing everything manually, Terraform handles the setup for you. For example, we can install NGINX on Linux, install iOS on Windows, run custom setup scripts. Now, an important question is, what language do we use here? Provisioners don't have their own language. They use existing scripting language like Bash for Linux and PowerShell for Windows. So Terraform is not replacing these tools. It's simply executing them during deployment. In this project, we are going to build a simple but practical high-level scenario. We will deploy two Linux virtual machines using Terraform and then automatically install NGINX on both of them using a script. After deployment, we'll verify that each VM is working by accessing its web page. You can imagine that in a real production environment, these two VMs would sit behind a load balancer, which I'll cover in the next videos. If one VM goes down due to the planned maintenance or an unexpected failure, so even though this is a simple setup, it represents a real-world high-level design. Before jumping into the code, let me quickly jump into the Azure portal and show where all these IoT things actually live. So here on Azure portal, if I click on virtual machines and if I click on create virtual machines, and here we go, we can see the IoT options. And this is where Azure basically asks us, how safe do you want your VM to be? And if I click here, you can see IoT zones are grayed out. So if you ever see this, don't panic. It's not you, it's the region. This region doesn't support availability zones, so that's why we can select it. Let me to switch something else like ACUS. So now you can see it's available. So if I select IoT zone, you can see here and you can select zone 1, zone 2, and zone 3, and you can see the price is going up as I selected zone 2 and zone 3. In real life, you'd usually spread your VMs across zones, not put everything in one and pray, you know. So let me change it to availability sets, and we can go for availability sets. So let's create one. For example, availability set. If I click here on availability set, here we can configure fault domains and update domains. Fault domains are basically like different hardware racks, and update domains make sure Azure doesn't restart everything at the same time and ruin your day. You can also set the maximum number here, and Azure will spread out your VMs across them automatically. So yeah, a less chance of everything going down together, which is always a good thing, you know. And and here Azure is like, are you sure you don't want to uh, create a scale set or create a VMSS? with VM SQL sets, you don't just create one or two VMs. You create a bunch of them, and Azure can scale them automatically. And this is usually used with load balancer when things get more serious. All right, so that's where all these options live in the portal. Now let's go to the Terraform and actually build these things properly. Let's talk about the code structure. In this project, we are going to build a simple but practical high-level scenario. We will deploy two Linux virtual machines using Terraform and then automatically install NGINX on both of them using a script. After deployment, we'll verify that each VM is working by accessing its web page. You can imagine that in a real environment, these two VM would sit behind a load balancer, which I'll cover in the next videos. If one VM goes down due to planned maintenance or unexpected failure, Azure will protect the workload using availability sets or availability zones, and load balancer will redirect traffic to the healthy instance. So even though this is a simple setup, it represents a real-world high-level design. Let's go to VS Code and check our code for this project. Now let's start with the main file because it gives us the overall flow of the project. First, I create resource group, which is logical container for everything in Azure. After that, I call network module and then I already set module. I like this design because as you can see, the main file stays clean and readable. Instead of mixing all resources in one line file, I'm using modules to separate um, the responsibilities. You can see Availability Sets, Linux VM, and networking. I'm calling the same VM module twice, one for VM1. If I come here, one for VM1 and one time for VM2. So I don't need to write the VM resource twice manually. I just reuse the same module and pass different values. And as you can see here, and also you can check the comments and you can find my GitHub repository link, and you're gonna have access to all these codes that I created on the videos. So both VM use the same networking outputs. Both also use the same availability set ID. That means they are part of the same high availability design. Another important details is the custom message. I pass different message to each VM. So you can see here, hello from web VM2 and also hello from the web VM1. So later the script can generate a different Nginx page on each machine. So these two rules are critical in this demo. The SSH rule opens up port 22, which Terraform needs to in order to connect to the VM after it's created. Without it, the provisioners that we use in a script, let me correct this, provisioners uh, would fail because Terraform would have no way to copy the script or execute commands remotely. The HTTP rule opens port 80, which allows us to reach the NGINX web page from the browser. So this is a nice example of how the network layer directly affect both automation and validation. And you can see this one destination 22 and also destination port is 80. Let's go to availability set. In this availability set resource, in this part of the project, I'm not using availability zones. I'm focusing on availability sets, which improve resilience inside a single data center where multiple VM are attached to the same availability set. Azure distributes them across fault domains and update domains. So that means one hardware issue or one planned update is less likely to affect both machine at the same time. Let's go to availability set and check the setting. So it's here. And this is the line that connects the virtual machine to the availability set. Since both VM1 and VM2 receive the same availability set ID, both machines participate in the same HA design. So this line may look small, but architecturally, it's one of the most important lines in the whole demo. About public IP, let me find it. Yeah, it's here. I'm creating a public IP for each VM. In a more advanced production design, we might put a load balancer in front of the multiple machines, but in this demo, I intentionally kept it simple. I want to access each VM individually so I can prove that both virtual machines are deployed, both machines are configured, and each one shows a different NGINX page. So the public IP here is mainly for testing, demonstration, and also browser verification. So now we move to automation part. Let's talk about this. The file provisioner copies the bash script from my Terraform project into the Linux VM. I prefer this approach over putting every command in line because it keeps the Terraform code cleaner and makes the script reusable. Also notice that connection block, since this is a Linux VM, Terraform using SSH to connect, and it uses the public IP of that VM to do that. This is a really powerful because now the same script can be reused for both machines, but each machine still gets a different final result. So instead of writing two different scripts, I keep one reusable script and drive the behavior into the values. If, for example, if you come here, you can see different, I'm going to pass different message and different contents for both web pages. And if I go to scripts, it's here. So you can see it here. This is the bash script that actually runs inside the VM. Since these are Linux machines, I'm using a shell script with a .sh extension. The first important detail is message $1. That means the script receives the first input parameter and stores it in a readable variable. Then I added a delay and retry logic. So this is a practical improvement because fresh Ubuntu VMs are not always immediately ready for package installation. Sometimes cloud in it is still working or apt is temporarily locked. So the script is designed to be more reliable, not just functional. You can see there here. So if we go to HTML code, after Nginx installed, I enable the service and restart it. Then I generate a custom HTML page and write it directly into the default Nginx web route. The key detail here is that the page content comes from the message variable. That variable originally came from Terraform that I showed earlier. So the full scenario works like this. Terraform creates the resource group networking availability set, then it deploys two Linux virtual machines inside that same availability set. Each VM gets its own NIC and public IP. After the VM is created, Terraform connects over SSH, copies the Nginx installation script, and executes it. And a script installs NGINX and create a custom page using the message passed from Terraform. Um, Finally, I can open public IP of each VM in the browser and verify that both virtual machines are working and each one shows a different page. So, and what I like about this demo is that it combines several real cloud concepts in one clean example. We have modular Terraform design, Azure networking, NSG based access control highlighted through Availability Sets, and post deployment automation using provisioners and scripting. So, even though the demo is simple, the design principles behind it are very practical and very real. So let's go and run the code, and after that, I'm gonna verify the results. I'm gonna run the code. So if I say server here, it's gonna initialize our code. So it's done. And then let's go and do plan. So Terraform plan is done. If I check it, we can see 15 resources to add. So we're gonna have VM1 and VM2 public IP, and then we can check our Nginx web page. So I'm gonna say Terraform apply. So we're done here. So as you can see, we have um, two public IP addresses of our Nginx or our virtual machines. So let's verify the deployment. First, I'm gonna open the public IP address of each virtual machine in the browser. You can see hello from WebVM1 IoT set demo. And if I go for the second one, you can see hello from WebVM2. This confirmed that the scripts were executed successfully on both virtual machines. Now let's go to Azure Portal. If I open IoT set, let me search it. IoT sets. So if I open it, you can see both virtual machines here. So and they are part of the same set. And Azure has automatically distributed them across different fault domains and update domains. Since we are not using load balancer in this demo, it's not possible to properly test automatic failover. But in real scenario, a load balancer would redirect traffic to the healthy VM if one of them fails. So you can see both of them are running. So if, for example, if we had a load balancer, if we shut down one of them, and the traffic is going to redirect to another one. And you can see here it's fault domain 1 and 0 and 1 and update domain 0 and 1. In the next part, we'll dive into Azure Key Vaults and learn how to securely manage secrets in Terraform. We'll also explore the difference between count and for each and when to use each one in real scenarios. This will help you write cleaner, more flexible, and more scalable Terraform.